Hi everyone, and welcome to the first
everyone.
of
Welcome
this
to the third
series
of
of
this
functional
series
tests.
of this.
We are a group of Italian developers in love with functional programming, and we back in 2020 we wanted to organize a conference to gather all the different souls and communities which gravitate around functional programming in Italy and abroad. But of course, things go wrong sometimes, so we turn to a series of online events. If you want to catch up with the previous talks, you can subscribe to our YouTube channel and look and watch the previous meetings. Let me give you our contacts. If you want to keep in touch with us, you can find our handle on Twitter is FunctionalFest. Our YouTube channel is FunctionalFest, and you can subscribe to it. Or you can go on our website, www.functionalfest.it, for news and future talks. Okay, let me also thank Wloop for their technical support and providing us the infrastructure for the streaming event. Our speaker this evening is Liu Ju, which we talk about peeling zeros in Idris. And if you have any questions during the talk, please drop a comment on the YouTube chat and we will ask you to answer. Okay, thanks, Ju.
Cool. Can you all hear me? Great. Yeah.
Welcome, everyone.
Oops, sorry. Cool. So let me share my screen. I have some very few slides prepared. So there we go. Okay. Great. Peeling zeros in Idris. So my name is Ju. I was born in China. So, you know, I ate a lot of noodles and dumplings. Then I grew up in Italy. So I ate a lot of pizza and pasta. And then now I live in the UK. So I drink a lot of tea, I guess. I work for a company called Red Ink, where we teach writing to kids. Yeah, feel free to check it out. And you can find me online as rcam with a 4. Right, coding time. So I had only 3 slides prepared. So bye-bye, that's it. Awesome, FunctionalFest. So I thought that maybe it would be good to do a very short introduction to Idris. I'm not going to talk about like all the features or anything like that. I just wanted to show you why I think the language is interesting, and then we can look at this practical example of like, you know, what all these things can help us write, right? So if I open, I hope everybody can see okay. But, you know, like we know how to write functional programs, right? Like you write a function, you can write a type signature, something like this. And you say, I get X and Y, and I just sum them together, right? And if I open this file in the terminal, I can just do add 10, 20, bam, 30, yeah? This is very nice and easy. And as usual, we would expect, you know, if we pass something which is wrong, the type system will help us to understand that, oh, we passed a double, but we said that it was going to take an int. So the compiler just stops and says, well, you made a mistake, right? And I think this is, you know, like what you would expect from many statically typed functional programming languages. Like you can work with values and you define these types, and, you know, basically you just can build like very big programs with like these very simple abstractions. I think the particular thing about Idris is that you can write functions at the type level. And by type level, I mean that when you do something like surprise, you can take a Boolean. And this thing instead of returning an int or a string or our own custom data type, it can return something special, which is called a type. And a type is just like any other thing, except that it's a type. So Idris usually also comes like with some developer tooling to help you out with stuff. So right now, I can tell Idris, well, can you please write a definition of this function? And Idris will take a look at this and say, oh, you said it was a bool, so I'm going to create this, empty definition. And now I can ask Idris, well, it's a bool, so can you help me out there and write down the possible values of that Boolean? And if I do that, Idris will say, well, I know it's going to be false or true, so I'm just going to write down all this stuff for you, right? And now I can also ask Idris, well, what do you think this thing should return right now? And probably Idris will be, Idris will say, I don't know, like you told me it's a type, so I don't really know what I should write. Okay, so in our case, I'm just going to say if it's false, we're going to return a string. And if it's true, we're going to return an int. And if I run this, it compiles. If I refresh the file, I can just say surprise false. Cool. And you see, surprise false is a string. If we do surprise true, it's an int. You're like, well, this is interesting, but it's hardly useful, right? Like, it will never happen to me that I want to create something like that. Well, how about we have a function which we call is foobar. It takes a number, which is an int, and then we take a Boolean. And what we return in this function is surprise of that B. So basically, we'll write a function that, depending on some inputs, will return either a string or an int. And as usual, I can just ask Idris to keep, helping us out to write the code. And you can see in this case, when I ask Idris of some more information, it will say, oh, I know that that thing needs to be a string, because it was able to run the surprise function to check that we actually want a string. So it has more information about what we want to do. So in this case, I can just use cast to turn that integer into a string. If I ask the same information here, it will say, oh, foobar RHS2 needs to be an int. And guess what? In the input arguments, I already have an n, which is an int. So in these cases, we can ask Idris to sort of, play this very stupid puzzle and try to solve it. And if we do that, Idris will just say, oh, okay, I found that I have this thing and you want something similar. So probably I just return the easiest way. Anyways, this thing compiles, we load it, we can call foobar 10 of true. You see, it's a number. And if I do false, it's a string. I think usually you just can't do this, like in many languages. Like in order to express these things, you'd have to create your own data type, string or int, and wrap them in some way. You have to have my string and it's a string, or my int, it's an int, or something like that. I'm sure that in TypeScript you can do anything, but anyways, I think this is like basically the cool thing that you can do in Idris. Like you can, as you can see, like you can specify some arguments, you can write some functions that operate on these arguments, and they just work in the way that you would imagine. I think, for example, in other languages like Haskell, you have to use a lot of language extensions. They are behaving slightly in weird ways, but that's not the case in Idris. I think it's pretty much, what you see is what you get. Okay, so this is as I promised, like the very short introduction to the language, just 5 minutes. Of course, the language is a lot more. I'm not going to explain it because I don't know much about Idris. I just, learned a few things. So that's what I'm planning to talk about today. So today, the talk is called Peeling Zeros with Idris. And of course, we're going to talk, about something related to zeros. So I'm going to start talking about the Beatles. Beatles, very big rock band, Liverpool, a lot of great songs. But what I want to talk about the beetles is that this very simple idea that usually we have this idea of a list. And when we want to get an element from the list, we usually write a function, right? And the function, we pass an index, it grabs something and returns it. So I have this little example in Elm where I just do something like this. You can see it's very similar. I'm printing hi mom, whatever. But I could say, okay, I want a beetle, right? So I'm going to use something like list extra get at. And I'm going to say 0 the beetles. And then down here, I'm going to say debug to string a beetle. And if I run this, you'll see it says just John. And the reason why it says just is because the type signature of this function get at is something like int. Then it takes a list of something and it returns a maybe of something. So it seems, like I'm so used to this. Like if you want to write a function which is safe and type checks, you sort of have to have this idea of a maybe, right? Because if I pass 10 to this function, the code can't crash, but it will just return, oh, I couldn't do that, right? Like it's like something that just gives us this sense of security. Like we have to handle this uncertainty, right? And I think this is great. But I think as human beings, when we look at this, it feels to me like something is wrong, right? Because I literally wrote down this list. It has 4 elements. And I say, get me the first one. But due to the type signature, we will always have this uncertainty. Like this value could be here, could not be there, but I know it's there. Like I just wrote it, right? But the problem is like we as human beings, we know this, but the type system doesn't know that. So it just has to treat that list of the beetles as it would treat any other list, a dynamically generated list, or something that we just created on the fly, or the result of a filter operation, right? So there's like this little disconnect between what we know as human beings and what the type system knows. And this is what basically introduces this little bit of friction, especially in these cases where we know that the answer is always going to be a just. But yeah, so great. So I'm going to show you like a little thing in Idris that we can use to fix this basically. Maybe I'm just going to swap my, yeah, that's better. So I'm going to use a module which is called vector. Right? And I'm going to save this, reload this. And if I ask Idris, what is a vect? It will tell me it's a function that takes 2 arguments and returns a type. The first argument is a natural number, so an integer number greater or equal than 0, a type, so something, and then it will return another type. Okay, so if I write it down here, I can just write vect, a number, 4, and string. Type, it type checks. What if I made a mistake? Don't read all the errors. The errors are long and big and complicated. But if you just look at this little red caret, you can see that it seems that Idris has understood something, right? It said, you said 3, but I'm struggling, because it was supposed to end there, but like something is not right. Like you can tell that the compiler has figured something out, right? So let me just get the code to compile again. And what I want to show you is like if I do VectIndex, which is a very similar function as the one we saw before, and we pass the beetles, you see it's just a John. There's no just John or some John. There's no this idea of something being optional. The compiler says, I know it's there, I'm going to give it to you. You don't have to handle the uncertainty anymore. And in this case, it'll be, well, but what happens if you pass like something else? Well, you see, it crashes. Right now, I'm not going to explain exactly why it crashes. That's why the rest of the talk is for. But rest assured that if you were to write this in your program, it would fail to compile. So basically, it gives you this guarantee that the compiler has understood a lot about your program and is able to give you these stronger guarantees about the behavior of it. Cool. I forgot to say this, but any questions so far? I'm going to drink some water. Okay, if I get any questions, I'll read them in the chat. All right, so where were we? Okay, you can see like this is what happens. Like you either get the value or the compiler just refuses to compile the program, which I think is quite nice. But how does it work? You know, like we can look and ask, how does this work? And you see, VectIndex takes this something weird, which is finlen, something regarding the length. It takes our vector, which is of certain length and contains something, and it gives us a thing, right? So, you know, like if we use Occam's razor, we know that there's no trick in here. This is just a container of data, and this is the element that we get returned. So it must mean that there's something about this thing which is magical or tricky, or you know, that there's something in there which does something interesting, right? So if we take a look at fin, we can see that it's another function. You take a natural number and returns a type. And there's also a way when you do doc fin that it gives you a bit more context, like what the thing is. So in this case, it says that fin are numbers strictly less than some bound, and the name comes from finite sets. It's not a good idea to use it for other blah, 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 and there's some code there. So I would like just to quickly copy this, and maybe I'll just open a split. So I'm going to remove all that and just keep, you know, this part. So we have it there, and we'll refer to it later. It seems a lot complicated, but we're going to unpack it like step by step. So as we said before, there's something magic in this fin, which allows us to do, you know, our index 0, you know, index 1, but it breaks when we pass like index 6, for example, right? There must be something in the type system which expresses this information. So what is that? I think we have to, you know, do a little step back, because there's, you know, a lot of symbols here, and I think it's not perfectly clear what's going on. So the first thing is natural numbers. This thing that we see here, this net. What is that? So normally, if I type a number and I ask the type of this number, it would say it's an integer, right? But there's this function in Idris when you can say the and then provide a type. So I'll say I want a natural thing, and I'll ask a 0. And if I ask the type of that, it will be a natural. So it's a way basically of saying this 0 literal can mean a lot of different things, but right now I want it to be a natural number, right? The fact is that the natural number is not really represented in terms of zeros. The natural number is represented using this, you know, relatively known little trick, which is to define a type where one value is 0. So this is one possible value, and the other value is what is called a successor. So the following number of a natural number. So as you can see, it's like a recursive definition. You can either be 0 or you can be the successor of something. So if I type z, you see it's 0. If I type the successor of z is 1. If I type the successor of z is 2. So this is just like a little trick. And you can see that there's nothing in the code which says that this thing is 2, but it's just like an optimization in the Idris compiler that will allow us to write these things as numbers, right? But basically, this is like, you know, there's no more trickery under the hood. It's just like this recursive type. You can either be 0 or you can be the successor of something. Let me just comment this out so the code doesn't break. But something else I wanted to show is that it seems that this thing is only useful to get the next number, but we can also write a function like this. We can write a function that gets a net and returns a maybe net. And I just, case splitting as usual. As you can see, like now, like Idris has recognized that capital Z is also 0, so it doesn't matter. In this case, there's nothing before the 0, so I'll return nothing. And in this case, I'll return just K, right? Just K. And now if I do prev of 0, you see it says nothing. But if I do prev of successor of 0 is like the prev of 1 is 0. And I can also write it like this. And as you can see, like using pattern matching, we're sort of able to remove one layer. So like we were applying the successor function, but we sort of undid that. So like in this way, we were able to go back one level. So from prev 1, we went to 0. And this is something that I think is not immediately evident when you look at it the first time. Okay, so this is our natural numbers, right? I just wanted to quickly point out, like the reason why we're doing this is like we have this special set of numbers, which for some reason, magic or wizardry, they can only be in a very limited set. So we're trying to figure out how does this thing work, right? And I think this SK thing, like the first time you see it, you have no idea, but now we know it's just the next natural number, right? So I think now we can go back at our definition of what fin is. Let me just remove also this header. It's just extra information. Okay, so now we have this idea of a finite number, right? And we can see that it has this function. You pass a number and you get a type. So if we just try it out, we can see fin 0. And if we ask what the type of that is, it's a type. If we ask the type of fin 1, it's a type. Fin 2, it's a type. So all those are types. Okay, so I guess like we've done this one, right? Time to move on to the second thing, which is FZ. FZ is a fin of SK. So this basically means that this thing has to be greater than 0, right? It has to be either 1 or greater than 1, because we know that the only way to express 0 is using Z. So if we're expressing something as SK, we're basically saying this thing is either 1 or greater than 1, right? So using we can say, if we want to create any value of fin 1, I can create it like this. And just to prove that the fin 0 type, you can't do anything with it, right? Like if I do that, Idris will say, this doesn't make any sense because I'm trying to create a 0, but I just cannot do that, right? Like this type signature basically forces me that fin has to be at least a fin 1. It can't be any smaller than that, right? So it's just saying, I think it's quite powerful. Like just like this single line of code is forcing that this constraint. And I think also another way of looking at that is fin 0 is a set which has no values. So like in a lot of languages, it will be called a void, a never. It's like a type. It's like a perfectly valid type, but there's no values that you can create of such type. It's like it's called uninhabited type, whatever. So as you said, like fin 0 is just a type. There's no values in it. What about fin 1? Fin 1, we've been able to create a 0 in it, right? It's just like one number. If we try to create a 1, it starts complaining again. It says, oh, I can't find an implementation. And I think now to understand why is that is we need to look at this fs function. Fx function goes from a fin of a number to fin of the next number, right? So when we say that we want, let's say, let me try to write it, right? In order to get a fin 1, we would have to provide a fin 0, right? And this would create this fin 1 that we want. But as we've seen before, we cannot pass a value of fin 0, of type fin 0. Like there's no thing that we can pass to this function to apply it. And therefore, by its own construction, you can't create more than one number. I'm sure now it's still, maybe it's not super clear. So I'm going to go on and try with fin2, right? If I try fin2 and I ask for 0, it's perfect, no problem. Fin1, now we were able to create this function that takes fin1 and gives us a fin2. And I think one analogy is like we have this set of finite numbers, and fin1 is the set with only 0. Fin2 is the set with only 0 and 1. And these are the only two things that we can create in this world. And for example, if I try to create, just as before, if I try to create something else, Idris just stops, says, no, this is not possible. And the same, for example, if I go on and I try with 0, 1, 2, 3, you see like it just stops at that level, right? And it never goes on further. And this is the reason why, when we get vect.index of 0 of the Beatles, this works perfectly. But the moment I try to do 5, it emits that error that for us was like a bit cryptic before, like cannot find implementation, whatever. But basically it's saying, from what you told me, I was trying to construct this value 5, but due to this definition of what a finite number is, I just cannot do that. It's like I'm unable to do that. So I think now we've seen how this thing works, right? Like, what are the consequences? But I don't feel like we truly understand the type trick, under the hood. Like, what's the thing in the engine that's like making this thing stop us, right? Like, I think we've seen like a little glimpse. So I just wanted to give a couple of like little hints on how to understand, like what the difference is. And one thing which I think is maybe obvious is that when I talk about this 0 and when I talk about this other 0, these two zeros are different. So let me just do this. I will do the fin1 of 0. And Idris would say, no, those two zeros, even though they have the same value for us humans, they actually belong to two different types. It's sort of like we're comparing apples and oranges, right? Like they're just of different types. They cannot be compared with like the equality operator. So I think this, in my mind, it makes sense. Like it's not that much of a stretch. We have a lot of zeros. So for example, even in the set of the first 10,000 natural numbers, that 0 is different from the 0 in the fin1 set. I think this makes sense to me. What I think doesn't make much sense is this. If I look at this and I look at this, I can see that this one is 0, as you said, and this is the successor of 0, which is 1. But actually, we're talking about two different zeros here. So just because they're written the same way, they're actually expressing two different zeros. So let me just show you what I mean, is that if we look back at this function, fs, we need to pass, in order to obtain our fin2, like our 1 of type fin2, we need to pass a fin1 to it, right, to obtain our fin2. So at the end of the day, it means that whatever we pass to this function has to be of type fin1. And therefore, it means that this fz has to be of type fin1. Of course, you don't believe me. That's fine. So I'm going to prove it to you. So if I create an fs of the fin2 of 0, and I say, is this equal to this thing? And it says, no. It says this thing is a fin3, actually. I'm like, what? Okay. What about if I pass a fin1 then here? Then it says, oh, now everything is good. So I think now, like, I've successfully proven that this fz and this fz are of different types, which is somehow surprising. Let's take fin4, right? And I just want to show you real quick what I mean by that. If you look at these 4 lines, the 0, the 1, the 2, and the 3, these FZ values, they're all different. So this one is of type fin4, this is of type fin3, this is of type fin2, and this is of type fin1. And if you think about it, if every time we add a layer, we go one next step, so this parenthesis becomes a fin2, this becomes a fin3, and after we apply the last FS, we get a fin4, like we desired, right? And that's the problem, you know, when you try to create something which goes over that. Like we would want to write something like FS of FS of FS, oh sorry, of FS of FS of something, right? But the problem is that in this case, we had a fin1. So we just cannot get any lower than that, like in our stack. Like here, it's basically, we start with this very beefy 0. It's very big, as like it's a fin4 0. And then when we get the next number, we peel off one layer and we get the 0 of type 3. And then we go another layer and we peel the 0 of type fin2. And then we go another layer, we get the fin1. But after this point, we're screwed. Like we can't go any further. And by the reason how, you know, these 3 lines of code are written, it means that you just cannot instantiate such number, right? And now I think like the error makes also more sense. Like you're saying, I'm trying to create an integer of value 4 in the realm of fin4, and this thing is just impossible. If I try integer to fin of 3, 4, you will say, okay, yeah, this is a valid number, or as is, you know, 0 or 2. But if I try 4, you will say, oh, I couldn't find a way to create an integer which values 4 within this finite set. Great. So this is the trick, right? And I think, you know, you're like, well, this doesn't seem very useful. It's like a bit annoying, right? Like you have to deal with this, like vectors, you have to specify what this thing is. It's just a bit painful, right? And as I said before, like maybe we think that computers should be able to do more than you know, what they do currently. So what if I told you that actually it's not necessary to use vectors? That in Idris, I can just do something like this: import data list as list, and I can save this, and then I can do list index 0 the vehicles. What? Like I talked for half an hour for nothing, basically. Is that it? Sort of. So as you can see, like now, like we just have a normal list. But somehow Idris was able to figure out that when I use this index thingy, something needs to be done, right? And if I try, for example, with index 10, it will crash. It will say, I cannot find an implementation for inbounds 10 for this thing. And I'm like, whoa, that's really magical, right? Because I thought before, at least we had the number there. So in a sort of way, you know, as a human being, I can understand how you do that. But now I didn't write it down, but still Idris was able to figure this thing out just as well, right? So how does that work? It's very similar to what we've seen so far. Like it's like the very similar type of type trick. So I'm just going to show you the type signature of the list index. Don't worry, you see, it takes like this natural number, you take a list of something, and then there's this little thing which is called like an implicit parameter. We're not going to go over what it means, but we can see that there's something inbounds, right? So if I ask about the documentation of what inbounds means, we can see that it's something that takes a number, a list of A, and a type. Which, if you think about it, it's very similar to how we defined the vector, right? The vector was net type, right? This one has a list of A, but if you squint, you know, hard enough, it's more or less the same thing, right? And if we look at the code, we have int first, which is inbounds of 0 of x cons to xs. This means this is a non-empty list, right? It's a list that must have one element. And my argument is like, if you look on the left-hand side, if you look at this, it's sort of expressing the same thing, right? Like we're expressing that this 0 has to at least have a 1 in it. It has to be 1 or greater. And in this way, we're saying this list has to have one element or more, but it has to have at least one, right? So I think now we've proven in one way or another that like this thing is more or less the same as the first bit. Let's look at the second one. The second one, again, let's squint hard enough. We see inbounds of k that creates an inbounds of sk, right? When we look at this, it's exactly the same shape, right? There's some other details about, how these, the length of the list is, you keep track of that. But what I'm trying to say is that it's the same sort of type trick, right? Like you are able in this way to sort of let the compiler automatically, unpack the list to see, oh, can I create a value which is of type in later or in first? And if you cannot create that, it will crash. Like if the program won't compile. So when I try to do list index of 100 of the Beatles, the program will say, well, I couldn't create such value, and therefore I'm just going to crash. But if you are able to pass a valid value, then the compiler said, no, everything's cool. Like there you go. Like there's no need to handle the uncertainty anymore, right? Like you can see like the compiler has this ability to look at the code and, just do more stuff with it in a sort of way. And this doesn't only apply to indexing, right? Like I think like another very common operation, for example, in Elm, that I think like a lot of beginners struggle is like, what happens if we just do a list head, right? If I compile this, even this thing returns a maybe, right? Because we don't know if the list is going to be empty or not. And in Idris, even that one is fixed. So if we have a list head the Beatles, it just returns John. If we do pass a list which is empty, it will give a very similar error to before. It was saying it's because it is going to say, I could not find an implementation of non-empty for this empty list. So it becomes a compile time error rather than something that you have to deal at runtime. Of course, sometimes you will have to deal with lists which are dynamically generated, and you will need functions that need maybes. But I think you can think a lot of cases when you're writing statically typed functional programming where you know that the thing is there, but you can't do anything about it, right? Like you can see it, it's right there, but the compiler just cannot understand that. And I think this is like quite a good solution for that. Yeah, I think that was all that I prepared. Feel free to ask questions in the chat, or also, like if you want to write to me, yeah, I'll be happy to chat about anything.
Okay, so first of all, thanks, Ju, for the nice presentation. And of course, as Ju just said, if you have any questions, please drop a comment in the chat so he can answer. Actually, while waiting for questions, I do have one. And my question is, I was just thinking about you told us that the compiler understands parts of our program. So we've seen that we cannot write some expressions because the program will not compile, so the compiler cannot understand them. Does that mean that we cannot write tests for for forbidding some behaviors of our program, or how can we write tests for that?
That's a very good question. I think the moment where that guarantee as the type level, you almost don't need to write tests for that behavior, because it means you literally cannot create such value. But of course, like, this sounds weird, right? Because you cannot, it just means you cannot create a value of type fin with that number. Of course, like, you can take any integer, right? Like, normally in everyday life, we deal with integers. So for example, that's why Idris does that little trick. It says integer to fin. And that's the function that you call to try to transform an integer into a fin. So it's like this, I think in other articles, we talk about this. It's this pattern, which is called the witness. So you run some validation and you create this special data type. And this special data type is the proof, is the living proof that this operation now is considered safe, right? Like, it could mean that, either this number now is safe, or your user has successfully authenticated. I think there's a very good Koenig blog post about, patterns in Haskell, where they talk about this pattern. And I think that's the place where I could see some tests. You try to, even, with normal tests or property tests, like, you want to make sure that the moment you're converting from integer to your special world, the errors are the ones that you would expect, right? But definitely at that moment, you have to create something like, you have to have a maybe or a result, or either, something to deal with the case to be able to handle it in the test. But I think normally in your code, if you're, let's say you have a map, right? And you want to grab this value and you just put it in, like, the value is there. Like, normally you just, like, you have these lines of code, you put something in the map, the line below, you try to grab it from the map and you have to deal with the maybe. So I think that's like the frustrating part, which for me, it's like extremely annoying, because, bro, I just put the value in there, just do something about it. But no, like, the type system cannot understand that. So you have to deal with that. So yeah, I hope that, like, is a good answer to the question.
Yeah, thanks. Okay, let's wait for someone else from the audience, if there are any questions.
I'm planning to like, write a transcript of the talk as a blog post, but I haven't finished it yet. So actually, it was very good for me to give this talk, because I realized, all the holes in the logic. And also, I'm sure I said many things which are not right, because I'm not at all an expert in Idris. I'm just reading the book. But I think, there's like these little fun things that, I don't know, especially if you've done like functional programming for some time, there's like these pains that, like, you take for granted in functional programming, and seeing that some language is trying to fix those problems, I think it's quite, a breath of fresh air, to say. And maybe one day, they will get in Haskell or whatever language you're using, we can hope.
Yeah, I mean, do you think that this approach can help you, modeling your business problem? For instance, if you want to adhere to DDD, for instance, where words and types and the model is very important. Do you think that this approach can actually help you, like, including the constraints of the business model in the type system and in your program in the end?
I think, every little bit helps, right? I think, like, the moment you're able to express some of these constraints at the type system, it means that no one will ever be able to break that assumption. I think I read a very good blog post many months ago about the difference between dynamic programming and, like, dynamically typed programming and statically typed programming. And they talk about this idea that types and tests there's sort of like a big claw, right? So tests help you to figure out, these edge cases of your system, and types help you to raise the barrier, the threshold of what is acceptable, right? So there's sort of, these two teams working for the same goal, which is to try to write software which is a bit more stable than what we used to write. So I think it's just like they are both trying to attack the same problem. Tests are trying to poke at the system like in a lot of different ways and try to find values or edge cases that will break the logic somehow. And instead, this type system basically gives like these strong, solid guarantees that these things will never be broken, or if we want to change them, by all means we can change them, and then we just have to make sure that these promises will never be broken. So I think it's quite nice to think of it as these two things, working for the same goal. I think I'm saying this because I used to do a lot of Ruby, so I think a lot of people in the Ruby community, they're very much into tests, but they're not much into types, which I find it hard to understand, because at the end of the day, you're just trying to write a program with less bugs. So
I do agree. We have a question from the audience, actually. Bor, I hope I say it well.
yeah, I can read it.
Yeah, please.
Yeah, I can read it. So I think Ford said, the error message that when you put more elements in the vector that was specified was not very specific. So just to say what I mean is that, for example, if I say vect of 3, I have to import this again, and I think something. No, okay, sorry, my bad. It says many things which are weird. It says it can be a vect, it can be a list, it can be a stream. And I think this is because under the hood, when you're writing this literal, which is like the square bracket, in Idris, it can be any of these three things. So that's why it's like a bit confusing, the error message. But I think the one that we care about, let me just empty out so I can, no. Okay, let me just do that again. Perfect. The one that we care about is this one at the top, right? It says, and I think when you read it like with some time and patience, it makes perfect sense. So it says, I'm trying to resolve this equation where on one side I have vect of something greater or equal than 1 of a string, and the other side of the expression is a vector of length 0 of such string. And it puts the caret there. So basically, the problem is that we said it's going to be a vect 3. So when it gets to this point, Idris says, you were supposed to give me at least one more element. That's what it means. Like, this has to be 1 or more. But actually, no, sorry, the opposite. You were supposed to end there. You're supposed to get something of length 0 at this point, but I can still see something, right? So if I change this and I change it to vect6, for example, we can see the error in that case. And you can see that now the error is sort of similar. Now it's saying, I was expecting this to have 2 more things, but actually just finished straight away. So you can see that it's actually quite good, the error message. I think it could be improved, but I think in general, it's expressing this thing that we said that it was going to take more stuff, but actually it's over. And also, like, I think the caret, basically, you don't need to read any of the error messages. Look at this, you're like, oh, there's some problem with the length of the list, very much probably. And instead, like if you pass the right number, it just compiles straight away. Perfect. No problem. Cool. Any more questions? I think we can call it a day.
Yeah, of course. If anyone has have any questions which comes to mind later, just drop a message on this very chat, and Ju, I think, or just cite Ju on Twitter, and I think he will answer. Okay, so let's thank Ju again for this very nice talk. I think we can end here. And also let me thank Double Loop again for providing support and the streaming infrastructure. Let me also remind that if you want to be notified and want to keep in touch with us and the next events, you can subscribe to the YouTube channel, follow us on Twitter at FunctionalFest, or just land to our website on www.functionalfest.it. I will also announce the next speakers. Next month we will have Marco Sanpellegrini, and in December we'll have Dmitry Kovanikov from Kovaniki, which you also cited earlier. So let's thank the speaker again, and see you next time.